main presentation. I will do the introduction. So it's about site attestation, browser-based remote attestation. We presented this work at the security workshop recently at EuroSys this year. And maybe Luca, you can step to the next slide. So the background idea was, in our case, I worked a lot on the various topics in confidential computing, but then I stepped away from my academic career and was 1 year in Switzerland and worked for Dfinity. And there we have the issue that we have a decentralized infrastructure providing a Web3 blockchain like environment. And typically you like to get a good user experience. So anybody that has a browser should be able to access such a Web3 environment. And of course, things happen simply in the browser. So you can get direct access to your smart contracts that are actually served by a distributed set of machines. And sadly, the browsers are not able to speak the native protocol of the IC. So of course, you could ask for browser providers to integrate a really nice distributed protocol to access your Web3 environment, but this is quite complicated. So you won't get buy-in from the browser providers. So the idea is mainly to have a set of distributed machines around the internet computer, HTTP gateways that take the requests of end users and transmit them and transform them to the Web3 IC protocol to access safely and securely the internet computer. Now the HTTP gateway becomes a bit of a complicated component because the question is who is owning them, who is operating them, and so on and so forth. And so the end users have to put a certain trust if they go via the HTTP gateway in the providers of these gateways. So we were thinking about cryptographic methodologies or other ways to secure the HTTP gateways. In the end, one option that we came up with, simply we provided them as a confidential virtual machine. But then the question is, how is this confidential machine attested? So, and who is doing it? And how can we integrate this quite leanly in the browser? Again, simply integrating remote attestation in the first place into the browser is not a thing that we could convince doing, for example, major browser providers. So we first had the idea to have a web extension and implement it in the web extension. And we had something which is quite nicely for Firefox. For Chrome, it's much harder because of certain restrictions for web extension. And this work together with how we crafted the virtual machines to be HTTP gateways, we published in a joint paper in middleware 2023. So trustworthy confidential virtual machines for the masses. And then there was some follow-up work where we did more of a runtime attestation of confidential virtual machines on the container level, customized for certain users. That is the work from 25 that is addressed. But this work, both of works are nice, but they are not really giving you the full security you want to have with remote attestation from a browser perspective. The web extensions have certain limitations. Yeah, for example, if you have web workers and there might be connection interrupts and so on and so forth. So we had the problem that the web extensions are not totally sound when it comes to remote attestation, all kinds of difficile connection management. So that was the point where when I was back at university, I was asking Luca and saying, Luca, hey, we need to get into the browser and we need to fix the browser so we can easily perform remote attestation from the browser side along with some custom policies that the user can define, so he can define which virtual machines to trust or not to trust. And this is the work he will present today. Also, we went into a different direction. We said we might have the possibility that assume you have a certain number of certificates for a certain site, which you can collect via certificate transparency monitors, and you can validate that for all of the certificates that are currently on the market, there is a remote attestation result which is suitable. So if you have a service that is sitting somewhere on the web and doing continuously monitoring of the certificates and the attestation results, then with high probability, even a user who's not aware of confidential computing could get an enhanced security when he accesses a remote virtual machine. This is something we also finished with more or less, and it's currently in the publication process. So this gives you an idea about the background about this work we did. In the past, my research group was happy to work with people from Intel, with various companies, with Definity, and so on and so forth. So we are always happy to have exchange and collaborations with industry, obviously, because confidential computing is always hardware, software, and it has a lot of industry traction. That's also, I guess, why I'm here, and we are allowed to present our work at this point. So with this, I want to hand over to Luca, and he can give you the details about the actual work we did in this paper. Thanks.
Okay. Thank you, Rüdiger. Okay, so let's get into the topic. Um, First, that everyone's on the right track, let's quickly rewind the concept of confidential computing in a few sentences. So the generic idea we saw is that the idea is to protect any services from external access and to make services cloud providers or service providers host in the cloud um, remotely attestable and yeah, to remotely attest the security guarantees. But so far, this proved especially useful for outsourcing services to cloud providers. But there are several, and there are several types of confidential computing available. Um, One are enclave-based approaches, and the second are confidential virtual machines. One of those is AMD SEV SNP, and we based our work on that. The nice thing about confidential virtual machines, we think, is that they are more accessible since you can protect whole VMs, um, which makes it easier to migrate existing services to that. Um, yeah, but however, site attestation is applicable to all forms of confidential computing. The status quo is that service providers often host their services in the cloud, and the service owner can protect its service from privileged systems like the host OS or the hypervisor through confidential computing. However, security guarantees on the user side are far less extensive. With HTTPS, it is ensured that the connection terminates at the owner's VM and data in transit is protected. But apart from that, users have no security guarantees. They can't know if a service is trustworthy or hosts malicious code. Thus, users must rely on the domain's reputation. And because of this, we think end users who can currently not access remote attestation due to, for example, missing technical know-how could greatly benefit of the security guarantees of confidential computing like remote attestation. Though there are a couple of challenges to face to integrate remote attestation into a browser, which makes it easier usable for users. The first one is how can a browser identify websites protected by confidential computing, and could there be a standard way? The second one, how can users validate attestation reports for remote attestation? And the third one, how could users interpret the validation results? Let's quickly cover how AMD SEV SNP, which we use for our implementation, works. Every SEV SNP capable machine hosts the secure processor. It is used to integrity protect the CVMs from privileged entities like the hypervisor by encrypting the CVM's memory and registers. And in addition, it takes a measurement of the CVM's initial state on deployment. This measurement can be requested from the CVM by a remote party alongside any user-defined data from within the CVM in the form of a signed attestation report, and by externally providing data that is then expected as the user-defined data in such an attestation report. External actors can force newly generated attestation reports. So, for example, you can provide a nonce, which is then expected in the attestation report, which means that the attestation report had to be generated freshly yeah. And if the CVM is configured with full disk encryption and by omitting any interfaces for reconfiguration like SSH, the CVM's state is fully protected and cannot substantially deviate from the initial state that is included in the attestation report. Thus, a CVM is considered sealed. When combining this with publicly available source code and a deterministic build process for the CVM, the measurement can be reproduced externally, which makes the CVM state remotely attestable. But how do we exactly request the attestation report from a CVM? With site attestation, the attestation report is obtained as part of the TLS connection establishment. We use the approach brought forward by remote attestation over TLS, RATLS for short. The idea is to exploit TLS 1.3 handshake extensions, which enable the user to send arbitrary data alongside the messages sent during the TLS handshake. We let the browser piggyback the attestation request onto the client hello message alongside with any data we want to be packed in the attestation report for identification purposes. For example, the nonce I already mentioned. The server then notes the identification information and creates an attestation report for the client, which is then sent to the client via the server hello or certificate message. And the client can then validate the attestation report on its side and validate the identification information. And should a server not respond with an attestation report, it is deemed not to support remote attestation. Yeah. So let's come to our contribution. As discussed, end users currently cannot validate or even see a CVM's protection, and site attestation is set to change that. We assume an attacker model typical for confidential computing. We want to avoid any access from third parties, but vulnerabilities of the application itself and side channel attacks are out of scope. Site attestation itself is built as a web extension for the Firefox browser in order to keep as much application logic out of the browser as possible, but we had to build a generic API for Firefox to make TLS connections available to web extensions or the TLS connection establishment. When a user accesses any website using HTTPS, the browser will establish a TLS connection to the host using a TLS handshake. And like explained in the background, site attestation will then send the request alongside with identifying information to the host via a handshake extension. In our case, the identifying information can be one of two types. Either the client sends a nonce, which then has to be included in the attestation report. We call this instant freshness, since the attestation report, like I mentioned, has to be generated on demand to include the nonce. And furthermore, always information about the TLS certificate is included in the attestation report to prove it was generated on a machine that has the hold on the certificate, preventing man-in-the-middle attacks. Though in our evaluation, we found instant freshness greatly increases latency when connecting a lot of clients in parallel. To prevent this bottleneck, if no nonce is sent, the attestation report can be cached by the server and will only contain the certificate information. In the case of instant freshness, like shown here, the host hashes nonce and certificate information and generates an attestation report with it, which is then sent back to the client as part of the server hello message. On the client side, the hash is created independently from the sent nonce and the server certificate received during the TLS handshake, and in proving the hash is equivalent, site attestation shows the attestation report was just generated on the machine the TLS connection terminates in. And the extension then notifies the connection handler and the user about the result, and the connection can be fulfilled. So that already solves two of the challenges we faced. The browser can now attain and validate that attestation report, but if the measurement included in the attestation report is actually deemed trustworthy is still an open question. So let's cover this. In order to solve this, we propose three security policies. The first policy builds directly upon the first policy is the exact match policy. The browser can be pre-configured with a measurement of the expected CVM's state. And should the CVM not send an attestation report, an invalid one or one with a wrong measurement that not matches the pre-configured one, access to the site is blocked with a warning. The second policy directly builds upon the first one, and we propose online repositories of trusted measurements. These could be published by the companies itself or third-party security organizations. And is a website covered by such a repository, site attestation can automatically validate the site's measurement with the one found in the repository. The third policy builds upon a feature of attestation reports, which can be signed by the service owner itself, and site attestation can be configured to trust such owner keys and thus will trust any attestation report signed by it. If no policy can be applied due to missing pre-configuration, the user will be prompted to decide via a dialog. So that covers also our third challenge, and users in their commodity browsers could now benefit from remote attestation. If site attestation is successful in validating a website, a checkmark will appear in the URL bar, like shown here, similar to icons shown for HTTPS connections. And when clicked, this shows a pop-up with further information about the remote attestation process. Now we come to the evaluation. We had 4 evaluation questions in mind, 2 of which focused on the server side and 2 focused on the client side, or rather the interaction between client and server. But for time reasons, I will only cover the latter 2. The first one is, what is the increase in latency when establishing a connection to a site attestation-enabled website? And what about already established connections, so only running GET requests or general HTTP requests? For our baseline, we measured the latency of an HTTP GET request without site attestation, once including the connection establishment, which yielded 145.9 milliseconds on average, and once on an existing TLS connection with 69.5 milliseconds. We then ran the exact same HTTP GET request with site attestation enabled, and the results, including connection establishment, yielded 305.2 milliseconds for instant freshness and 242 milliseconds for certificate freshness. For the existing connection, latency was on par with the baseline with 70.3 milliseconds. And that's the important thing, that the requests for existing connections don't cost a lot more latency, as TLS connections are reused with HTTP2. We think the increase in latency for the connection establishment is very manageable and outweighed by the advantages site attestation hosts. So let's conclude. Site attestation proposes to secure websites through confidential computing and to perform remote attestation using trustworthiness policies while surfing the web. And with this, site attestation makes the advantages of confidential computing accessible to end users and reduces the need to blindly rely on a website's reputation, while keeping the browser quick and responsive with little latency increase. And since this is an industry talk, let's quickly cover opportunities for the industry. The first and most important action would be to extend major browsers with a general API that allows browser extensions access to TLS connections, and furthermore, build a standard for remote attestation in the browser, which could then be implemented by various browser extensions by industry or by the community. The whole project, including the patched Firefox browser, the patched Nginx, HTTP-perf, which we use for evaluation, and the web extension itself can be found on GitHub. Thank you for your attention. Oh, I oversaw the hand. Fritz.
No, I was just queuing.
Okay.
Thanks for the presentation. Then it's fine if I just immediately start right with questions.
We've got quite a few questions in the chat, so this is good.
So I was just wanted to go first because I was realizing mid talk that I was throwing you into the sharks pool here with letting you run into attested TLS discussions without prepping you about the context. So the CCC has also special interest groups, and one of those special interest groups is the attestation SIG. And I think for over a year, there have been endless discussions on attested TLS in terms of pre-handshake attestation, like combined handshake attestation or post-handshake attestation, etc. And so that's just what was the context that I wanted to give you, and then ping back the question from chat directly to you, so you can like precede any of these questions. Does your extension care at all about what TLS protocol or embedding of the attestation into the TLS protocol choice you make? Or in the end, you don't care, and for you, it's just an implementation decision on what TLS ends up being, and for you, the whole package around it is important, because I believe it's a letter, but I want to give this to you.
So you mean the implementation of TLS in form of OpenSSL, or?
So there's, I think, around like 7 or 8 implementation or protocols nowadays on whether you do attestation before TLS, or in contrast to then doing first TLS and then doing the attestation, right? Kind of the interplay between attestation and TLS. Do you embed it? Do you do it before, after handshake, etc., etc.?
Okay.
But so does it matter at all to you what you end up picking, or did you just pick any one of those that sounded good to you at the time?
I think we picked the one that sounded the best at the time, and which was like the easiest to implement. And what is implemented is like during the handshake to run the attestation, because that is also kind of important for the implementation, because if you do it after the handshake, you can't cancel the handshake. So the extension is set up to, if the validation of the attestation report doesn't work out, or if the user doesn't trust the website, then the TLS handshake is canceled and the connection won't be established. So you will never actually connect to a server that is not deemed trustworthy.
But from your engine perspective, that's just a choice of implementation, right? In terms of like, you could also cancel it after not reaching the final attestation, right? That's just a browser choice of like when it's canceled. Just, and then I'll yield.
It sounds like there may be a UX issue here, right? It's going to be confusing to the user if they create a handshake and then the attestation fails because you think you've got part way through. Is that my understanding, Luca?
Yeah, that's kind of the idea, I'd say. But
because I think the general feeling and direction of the attestation SIG is probably that post attestation is securer and the preferred approach. There's a link actually in the chat to some information around that you may find interesting, because I think it might be worth looking at that and then seeing what that does in terms of implementation and in terms of UX as well. And as Dan points out, we have another meeting on the 27th of that SIG, and you may be interested to come along. You may be interested to watch the videos of the last couple of SIGs, maybe, which are there.
Maybe one thing I can say about this, because I mean, for the different papers that I referenced in the beginning, we did various variants. Yeah, we looked at what original paper from Intel. Then, of course, in the first pass we first let the TLS connection establish, and then we're doing the attestation report exchange. That was one way, and then we decided to go with the handshake, because it seems to be that for browsers and so on, connection establish time is crucial. So because you have so many and so often, so you want to be fast. So that was why we said, okay, let's go with the user extensions, because we want to have a connection as fast as possible and not delay it. And then that would be another ping pong. And that's why I guess I suggested to Luca, we don't go through the tunnel, do it while we establish the tunnel. That was the thinking at that time.
I see the reasons for the decision. I think that is an entirely appropriate reason. I think what I'm saying is there's further research that could be done to see what impact that has, and what other trade-offs we should be making. Because you're quite right, that's a major issue, timeliness for human browsers particularly. But if we start thinking about what does this mean for agentic AI and browser type browsing, there's another question again. So I have another question which I was thinking of, if I may, Dan. I know there's other people. Dan, do you want to put yours in, or mine kind of is related? But shall I do mine, or up to you?
Go ahead.
Okay, so my other one is about rekeying, and people don't think enough about TLS and rekeying. It allows you to rekey, and it allows you to specify when you're going to rekey. And it occurs to me that actually there are times when you might, as a client, wish to rekey because what you want to force is another attestation measurement. And so that's actually a really interesting thing to be able to say from a browser. I actually want to basically remeasure and to use TLS native capabilities to do that rather than having to do it via another channel. And so, I mean, this may be beyond your initial thinking, but I'd be really interested to know if that sounds like that's something that's of interest to you to examine or to investigate.
To be honest, I don't really know what rekeying in this context means.
Luca,
so you can basically do another handshake. You can force another handshake, and it can be forced by the client, and I think also by the server. So yeah.
So,
Okay.
but usually I thought that rekeying involves that the connection is not really terminated. The connection and the cryptographic conditions hold during the rekeying. And if this is the case, then the attestation result should be, in the case that we pitched, still valid, because at least for confidential virtual machines, like they have been used in this case, it's only the initial context that has the attestation, right? That's why also we make it a more or less deterministic box.
I would like. Well, I don't believe in determinism because of the Turing hypothesis. But there are times I think when rekeying may make sense because you may be doing binary loading, for instance, into that, which makes determinism pretty impossible. And so I'm just wondering whether it's a possibility. It may not be, but I was just wondering if it's whether we can piggyback a forced reattestation over the protocol. And the answer may be no, because it's been 20 years since I looked at TLS properly. Well, 15. So I don't know what the state of it is, if I'm honest. Just a thought.
I mean, obviously it could be of interest if we acknowledge, and that's of course a point, that the virtual machine will evolve. So we have patches, we have configuration changes, we have a lot of these kind of things going on. But then, and this is also in one of the papers that we last year published, is to say, okay, then we need extended attestation capabilities in the virtual machine, for example, for the context that is actually subject to the reconfiguration. So we have a base attestation and then a layered one and so on and so forth. And if you have these kind of events and you know about them, then of course a reattestation is necessary because suddenly the dynamic context on the other side has changed and the guarantees are muted in the worst case, right?
Yeah. So, and I would say one of the pieces of work that Dan is proposing that we do might be relevant to some of that layered attestation discussion you've just mentioned. So please stick around and keep involved. That's my questions for now. Thank you very much indeed, Dan. I do apologize for taking up so much time, but you know what I'm like when I start running with the ball.
All good.
Thank you.
Were there other people that had questions?
Yeah, I just wanted to jump in really quick on Luca's behalf and say, Luca, you jumped into the midstream of a discussion that's been going on now for almost a year, where you jumped right into the middle of the deep end. Take heart. There are a lot of these presentations that get done here during the TAC where the question period comes up and not a single soul makes a single sound. Those are the hard ones, right? The fact that you are really getting engaged here is a good thing. It means that you're right in the middle of it. So keep going.
Enormously.
Good to hear that. Thank you.
It means we're interested, and interest is good.
All right. My question isn't necessarily for Luca or Rudiger to respond to directly, but just anybody. I think one of the one of the assumptions in the early slides is that you can launch this CVM with an encrypted disk. And I feel like there were some replay attacks that have existed without a monotonic counter available, or some other mechanism to mitigate those. And I'm just kind of curious, do we as a community feel like, oh, that's actually a solved problem? Dan, go finish reading up on things you should have read 3 years ago. Or is this still kind of open?
I can speak for Microsoft on this and say that it is not a solved problem. It is a problem that is under active development, and that we are looking at obviously the different operating systems that are in confidential VMs and the different technologies. TDX and SEV SMP are the two primary ones. So we are aware of the problem and are working towards a solution, but we don't have any announcements that we can make yet.
Okay.
If that's any of that research that's going on that is shareable on this forum, it'd be a great place to get more minds on it. I realize that some of it may be proprietary, but if there's stuff that can be shared, you will find people who will engage with that discussion. I am certainly one of them. So I'd love to talk about that.
I will again express my gratitude to Luca for bringing up such an interesting topic, and we'll commit to getting a tech talk from the folks here that are pursuing those solutions. It's going to be an add-on to the what is it, REFS, and I can't remember what that stands for. That provides rollback attacks and integrity protection for file systems based on BitLocker. So that's where we're heading in that direction, and I'll get the resident experts to prepare a tech talk at some point in the near future.
Great.
Thanks, Ali.
So maybe
Nicholas has a hand up.
Just a comment, I mean, regarding IBM Secure Execution for Linux, in these cases, you have the capabilities to have an encrypted image to start with, which is only deployable on that system. And with the latest generation, we introduced something which is called Retrievable Secret, which enables you from the outside to inject into our crypto accelerator so-called protected keys, which then could be used for encrypting your disk or your network backend.
Nicholas, to my knowledge, it's been about 5 years since IBM presented the architecture of that, and it's come on a lot since then of Secure Linux. And I would love it if you guys could present and tell us how it all fits together these days. I said it's been a long, long time. So, and I know there's been architectural improvements to it. So please, can we have someone from your team or several people from your team to walk us through how that all works, because that would be really useful too.
Yeah, we can do that.
See, Dan, I'll have the stuff for this year.
Could you just restate that though for me? That came at me kind of quick, Nicholas. The boot disk is encrypted and it's sealed with confidential computing. Was that what I heard?
It goes in further. The technology at itself works based on having for the confidential VM an encrypted image, which is encrypted with host-specific key to start with. With that, you can have an image only being deployable on a given host, which has a specific serial. We have other products in HyperProtect, which is building on top of that, where yes, the bootstrap of the Linux itself will create encrypted root file disks where only the enclave knows the key, as well as you can attach data disks for which you can create the deluxe encryption, also randomized, but reusable in a way that you have several seats you add in your specific contract. That's other things. I can talk about secure execution. I don't want to derail the discussion. I'm happy if Mike invites us. I can talk about the technology itself, as well as how we use it for our products, up to deploying it on confidential containers, confidential VMs.
Absolutely,
and stuff like that.
But just to put this right, I mean the point is to my understanding, of course, we seal to the identity of the virtual machine the encryption key of the disk, and the disk is encrypted. So there is no way, if you are not the right virtual machine on the right machine, to unseal the disk. fair point, and this is supportable. The point is more that if I get the version of the disk 5 minutes ago, or 1 hour ago, or 2 hours ago, this is harder to detect. For this, I need monotonic counter. The monotonic counters are too slow, and at least in the past they were too slow, or they were exhaustible. So I could make so many changes. So at some point there was an overrun. So the only solution that so far you have, and there are a couple of papers and of course also industrial implementations, that you use a distributed service that basically does a distributed monotonic counter for you. So you get for each change on your disk, you have to ask a remote infrastructure. Another approach was asking the client, this is my latest state. Is this state really the state I should have? And then I identify a reboot attack. These are the two software-based solutions, but to my understanding, we don't have a hardware-based solution that really has, a lot of monotonic fast counters that are not exhaustible. That just from an academic point of view, this is my background in this question.
And to add to that, you can also argue and you can also create a system around not needing rollback protected file systems for a TLS certificate, right? Because you can argue that you get provisioned a certificate, you seal that, and then you can maybe have that revoked, but as long as you do not allow overwriting in your current state or overwriting this in your current run, then any state goes, right? As long as you don't allow rolling back to no certificate, which is arguably detectable, then any certificate that you get provided is this certificates that you have, and you have certificates, authorities, and you have CRLs and OCSP, etc. for revoking this, but that's not in the scope of CTEE. That's something the client has to check anyway. So I think you can even get away without rollback protected file system for specific use cases. This may be one of them.
I think we have a thread around file systems and TEs that we should be looking into, because there's some really interesting questions coming up, and I need to see pictures. My head's beginning to explode. I'm also exploded by the fact that Rudiger still has a VI thing on his wall when Emacs is clearly the preferred. But let's not get religious at this point. Sorry, Rudiger, that's mean. Dan, sorry.
Yeah, just swallowing all sorts of responses about Emacs. All right. The other thing we're kind of tossing around loosely here is sealing. So SGX had hardware sealing support. To my knowledge, TDX and SNP, I don't believe they have hardware sealing support.
They do. Based on our research, they do. For SNP or SCV, it exists in a similar way, the same ideas. For TDX, you can use the SGX abilities, because any machine that supports TDX supports also SGX. So you can start. You need an SGX component to provide that sealing for a TDX TD in a way.
Actually, it's coming later this year. TD sealing keys. It's
already
cool. It's documented in the latest ABI, TDX ABI that's on our documentation site.
Great. Oh, incident! I saw Simon put out like a LinkedIn post saying, here's the coming soon ABI, but there was not like a diff, and there were other versions of documents that show a diff, so you could see actually what was changing. So if Intel could produce that would make it easier to see what was new there.
Okay, I'll check on that. I thought there was a what's new type link, but I'll talk with Simon.
Thank you. All right. Well, that was
sorry. Just to be clear, to be differentiating here, which Simon are we referring to? Because we have one on the call, and I suspect you don't mean him.
No, I think it's contextually apparent to the person who needed to know. But that was Simon Johnson.
Johnson, right?
Yes, Simon Johnson. Correct.
Okay, I assumed.
However, if Simon from Microsoft would like to update the TDX docs, that's also.
I was surprised.
More than willing to contribute, but I don't think I could offer that much into that at this stage.
Okay, great. So this was a wonderful talk. Clearly generated a lot of good discussion. Really appreciate you bringing it to the TAC today.
Yeah, thanks for having us. Sorry.